two particles A and B having charge Q and 2Q respectively are placed on a smooth table with a separation D. A third particle C is to be clamped on the table in such a way that the particles A and B remains at rest on the table under electrical forces. What should be the charge on C and where it should be clamped? Fine. Now let us say this is my charge A with a charge of plus Q, B with a charge of plus 2Q, and let's say the charge C is clamped somewhere in between them with a distance between A and C to be X. The distance between A and B is capital D as it is given in the question. Fine. Now the system is in equilibrium, so net force on C due to A will be equal to net force on C due to B. Fine. So just substitute the formula K into Q dash. Let the charge on C be Q dash into Q divided by X square, that is equals to K into Q dash into 2Q divided by D minus X whole square. Fine. On solving this equation I get 2x square is equals to D minus X whole square, that is root 2x is equals to D minus X. So root 2 plus 1 times of X is equals to D. So X comes out to be D by root 2 plus 1. So it can be written as root 2 minus 1 and root 2 minus 1. So X comes out to be root 2 minus 1 times of D. That is the answer. Fine. In the second case, I have to calculate the charge on C. So for that, what I'll do, I'll equate the force on A because it is given that net force on A is 0. So what I'll do is I'll equate the force on A. So I can write force on A due to C, that will be equal to force on A due to B, right? So substituting the formula K into Q dash divided by X square, that is equals to K into Q into 2Q divided by D square. So K gets cancelled, Q gets cancelled, and substituting the value X over here, Q dash divided by root 2 minus 1 to D square is equals to 2Q by D square. So D square gets cancelled. The value of Q dash comes out to be 6 minus 4 root 2 times of Q. That is the answer.